point, we've added, like we've given the concentration, we're putting it in pure water. All right, so it's just a regular KSP problem. Now we're going to start adding it to solutions that already have other ions in it. Today we're just going to do something that will start to precipitate one of the ions. In this case, we're going to add aluminum nitrate to 0.01 molar sodium hydroxide. The hydroxide that's already in the beaker will precipitate out with the aluminum. We want to know how much aluminum we can add before we get a precipitate happening. Okay? Tomorrow what we're going to do is we'll have what's called a common ion effect, and we'll already have a solution that has, say, some aluminum in it, which will lower the solubility or the amount that you can add to dissolve. Okay? So, how much or what's the maximum concentration of aluminum nitrate that can exist in 0.01 molar sodium hydroxide? And they give us the KSP for aluminum hydroxide. All right, so essentially we have a beaker that has OH minus in it. Do we care about the sodium? No, it's a spectator ion, right? We don't care about that. We care about the hydroxide because that is what's going to form the precipitate with the aluminum. All right, so what's the first step here? Always same first step. Write the equation. So okay, so we got our equation. Now, we're adding how much aluminum hydroxide? How much of this can we add? I don't care about the nitrate. So really, we just care about the aluminum and the hydroxyl. This is a nice table, essentially, but we're just going to shorten it. Now, how much OH minus is already in the beaker? 0.01, right? That's what's floating around in the beaker, 0.01 molar. So that means we have 0.01 molar OH. Do not multiply it by 3. Okay? Because where does this OH come from? It comes from this, right? It's not coming from this. All right? This is the precipitate equation. Okay? So it's coming from this. So if I say it's 0.01, that's what you put there. How much aluminum can we add? That's what we want to know. So how much? What do I put here? X. Unknown. I don't know what it is. It's X. It's a certain amount. Okay? Then what do we do? You just did a bunch of them. Write the KSP expression. It's going to be the concentration of aluminum times the concentration of OH minus to the power of 3. We know what the KSP is, and then we plug in our variables or our unknowns. So we get X times 0.1 cubed. 0.01, not 0.1. There we go. And then you're going to math it. Math is now a verb. And you're going to get okay. So 2.5 times 10 to the minus 12 molar. This is the maximum amount of aluminum that can exist in that solution before it precipitates. Because that's this number coupled with that number generates the KSP, right? So as soon as I add more aluminum, I get a higher concentration here, which then means KSP trial would be greater than KSP, so it pushes back, and you'll get a precipitate forming. So this is like this is the end game, like the maximum amount, the ceiling you can get to before you start to precipitate stuff out. Does that make sense? We're good? All right, one more question. It's a short lesson today. This is basically the same question, except now I've just added one more level. How many grams can I do this? All right, so we've done a few of these before. All right, so how many grams of magnesium nitrate can be added to 400 mils of a 0.2 molar sodium carbonate before a precipitate occurs? First thing you got to figure out is, what would the precipitate be? Do nitrates ever, do we have to worry about them? No. So we're not going to worry about the nitrate. Boom, boom. Do we worry about sodium? No. So it's going to be magnesium carbonate, right? Does that make sense? Okay, so MgCO3, solid. There's our equation. Okay. What do I know in this equation? What number do I know?
Sorry, hold on.
Okay, here's the precipitate equation. I'm trying to know how much of this I can add. In other words, how much magnesium can I add before we get a precipitate forming? So what number, that's going to be X, okay. What number goes under the carbonate? 0.20, right? Because that comes from this, right? And then it's the exact same, except that we got to look up the KSP of magnesium carbonate. I don't know what that is. 2?
No.
Just 2? 6.8 times 10 to the something? 6.8 times 10 to the 6. You guys are correct. All right, so KSP equals so you do that math and you get 3.4 times 10 to the 5 molar. What does that represent? That represents the concentration of magnesium, but because this is a 1-to-1, it's also the concentration of this, right? Does that make sense to everybody? If I know this, I know that that's the same. So that's going to equal concentration of Mg plus 2, which is equal to the concentration of MgCO3. Okay. But, sorry? Oh, yeah, you're right. Technically, it's not, but. I didn't ask for the concentration. What did I ask for? The grams. So then it's back to grade 11. So 3.4 times 10 to the minus 5 moles per liter of MgCO3. How many liters do we have? 0.4 because it's 400 mils. 0.400 liters. Anybody know what the molar mass of magnesium carbonate is? 84.3? That's what I have. I got 148.3 grams per mole is the molar mass of magnesium carbonate. Does everybody make that up? Somebody else back me up. Okay, now maybe. Now I'm not. 84.3? Okay, apparently none of. This is probably me. I'm doubting myself. MgCO. 84.3. Told you. I don't know where I got 184, 148. But we were both thinking the same thing. I don't know what we did, but we did the same thing. So it's 84.3 grams. So now I'm doubting my answer. Can somebody do the math and tell me what my answer is, please? It is 148. I just added it up. It's 148.3.
Okay.
I did mg plus, no, I did 24.3 plus 14 plus 14 plus 48 plus 48. What? It's magnesium carbonate, not magnesium nitrate. Oh, that's where we went wrong. That's what we did. See, that's what I realized. Because the 14, that's nitrogen. All right. What? So MgCO3. I'll even write that. Okay, what's the answer? 1.2 times 10 to the negative 3? Oh.
Oh, never mind. It is 1.1. I just counted something.
It's what?
It's 1.1. 10 to negative 3. This is not looking good. I did everything else right.
Grams?
Yes, yes.
Put your hand up if you agree with that number.
Sure, why not?
All right. There we go. Wow. So we did the math 12, the chemistry 12 stuff okay. We just messed up on the chemistry 11. We're awesome.